All right, let's get right into it. You know that feeling staring down a huge exam and it feels like this impossible locked box? Well, what if I told you that for chemistry, we actually have the key? Today, we are not just studying, we're doing something way smarter. We are cracking the exam's code.
No, seriously, just think about that for a second. What if you could walk into that exam hall actually knowing with some real certainty what you're about to face? This isn't magic, okay? It's pure strategy. And it all starts by recognizing the patterns that have been hiding in plain sight this whole time.
And that's our focus right here. We're going to zoom in on two specific, high-value questions that just keep appearing year after year. Seriously, if you master these two, you've essentially locked in a huge part of your final grade before you even pick up your pen. How cool is that?
Okay, first up is question 6. Now, this one is almost always about the study of compounds, and you can bet the two superstars of the show are going to be ammonia and hydrogen chloride. So, you ready? Let's start breaking down the first part of this code.
So the topic that comes up more than anything for question 6 is the Haber process for making ammonia. And look, we can just boil this down to 3 simple steps. It's like a recipe. First, you need your ingredients, nitrogen and hydrogen. Got it. Second, you need the right conditions, right? You got to crank up the temperature and the pressure to get things moving. And third, you need let's call them the magic ingredients, iron as your catalyst and molybdenum as its little helper.
So let's zoom in on that helper, the promoter. The crucial thing to get here is that molybdenum doesn't do the heavy lifting itself. No, its whole job is to make the iron catalyst work so much better. Think of it like a turbocharger for an engine. It just supercharges the entire process, makes it faster, more efficient. That's a key term you're definitely going to want to remember.
All right, so beyond the Haber process, there are a few other greatest hits for question 6 that you need to have in your back pocket. There's the fountain experiment. That's the classic visual that proves just how incredibly soluble gases like ammonia and HCl are. Then you've got drying agents. You got to know why you use, say, calcium oxide for ammonia, but sulfuric acid for HCl. I mean, it makes sense, right? You can't use an acidic dryer on a basic gas. They just react with each other. And finally, why do they use finely divided iron? It's all about surface area. More surface area means a faster reaction. Simple as that.
Okay, so code number 1 is officially cracked. You're on your way. Now for the second key. This one is for question 7, and it's all about metallurgy with a laser focus on one metal, aluminum. Okay, so for getting aluminium, it's all about the Hall-Héroult process. Now you start with bauxite ore, but here's the catch. Its melting point is over 2,000 degrees Celsius. That's just way too high and expensive. So here's the genius part. Step 1, you dissolve it in molten cryolite. Step 2, you add something called fluorspar, which is like a secret weapon to lower that melting point even more, saving a boatload of energy. And then step 3, you just zap Dolphin with electricity, electrolysis, and boom, pure aluminium is yours.
And pay attention here, because this leads to an absolute favorite exam question. During that electrolysis, oxygen is produced. But instead of just bubbling away, it actually attacks the carbon anodes and literally burns them away into carbon dioxide. This is why they have to be replaced periodically. It's a critical detail they absolutely love to ask about, so make sure you know it.
Here's another classic trip-up, roasting versus calcination. People mix these up all the time, but it's actually super simple. The key difference is just one word, oxygen. Roasting, that's when you're heating an ore, usually a sulfide one, with a strong supply of air. Think of it like a barbecue. Calcination, that's heating an ore, usually a carbonate, in the absence of air. So one's with oxygen, one's without. That is the only distinction you really need to nail down.
Okay, you've got the core concepts down. Now for the really fun part. Let's do a little rapid fire round. I'm talking about the exact questions and the perfect answers that show up with unbelievable regularity. This is your high-speed cheat sheet. Let's go.
First up, a total classic. You've just made hydrogen chloride gas in the lab. So why can't you just collect it by bubbling it through water? What's the problem?
Simple. The answer is super precise. It is highly soluble in water. It would literally just dissolve instead of you collecting any of it. That's why you have to collect it by the upward displacement of air, since it's denser than air.
Okay, next question, back to metallurgy. In the Bayer's process, for purifying bauxite ore, what is the specific job of the sodium hydroxide, the NaOH?
Its job is basically to be a chemical filter. It reacts with the bauxite, dissolving it into sodium metaaluminite, but, and this is the key part, it leaves the impurities behind. All that red mud stuff,
It doesn't dissolve, so you can just filter it right out. Clean and simple.
All right, one more for good measure. A classic observation question. You bring a glass rod that's been dipped in concentrated HCl near some unknown gas, and suddenly you see these dense white fumes. What's the gas?
The answer? Ammonia, NH3. Those fumes are actually tiny solid particles of ammonium chloride, NH4Cl, forming right there in the air as the two gases meet. That's a guaranteed point on the exam if you know it.
Okay, so we've looked at the past and we've mastered the present. So now, let's look into the future. Let's pull out the crystal ball. Based on all these patterns, we can actually make some highly educated guesses about what you're going to see. This is where simple studying turns into a real strategic advantage.
So, for our 2026 predictions, for question 6, we're anticipating a focus on the catalytic oxidation of ammonia, probably paired with a diagram question on the lab prep of HCl. For question 7, you really want to watch out for the Bayer's process. Know that flowchart. And for an identification task, get ready to tell the difference between roasting and calcination just from a written description.
So let's wrap this all up. Your winning strategy is just 4 steps. Super simple. 1. Recognize the exam patterns. It's not just a random collection of facts. 2. Focus on the stuff that comes up all the time, those high-frequency topics. 3. Master those repeating questions we talked about. And 4. Use all that insight to anticipate what they're going to ask you next. It's about studying smarter, not just harder.
So there you have it. We've laid it all out. You have the patterns, you have the core concepts, you even have the predictions. The code to this exam is officially in your hands now. The only real question left is, what are you going to master first?